Hi YouTube, Tim Uckert here. In this video we are going to solve logarithmic equations by using the power rule. Alright, so let's take a look at this first one. We have log base 2 of x cubed equals 21 and we want to solve for x. Well, we can take the exponent 3 here and we can write that as in front of the logarithm, so we can write it as 3 times the log with the base 2 of x, and we set that equal to 21. We can now divide both sides by 3 here, and we'll get log base 2 of x equal to 7. We can now write this in exponential form with the base of 2 to the power of 7 equal to x. And that's 7 2's multiplied together. So 2 times 2 times 2 times 2 times 2, that's 5 2's, times 2, 6 2's, 7 2's. So 2 times 2 is 4, times 2 again is 8, times 2 again is 16, times 2 again is 32, times 2 again is 64, times 2 again is 128. So x equals 128. Okay. Now, because we have an odd power here, we don't have to worry about a potential negative solution. We'll have one coming up where I'll show you why it could also be a negative solution there as well. Let's try another one. Let's go to problem 2. All right, so in this one we have the natural log of x to the 5th equals 35. We want to solve for x. Again, we're going to take this power 5 and multiply it by the natural log of x and set that equal to 35. We can now divide both sides by 5. So we're going to get the natural log of x equals 7. Now another way we could write the natural log of x is we could write it as log base e, with e being Euler's number, of x. So that's what natural log is. It's log with the base of e. So when we write this in exponential form, we're going to take the base of e and raise it to the 7th power, and that's going to be equal to x. Now, e is an irrational number, meaning after the decimal point it's non-terminating, non-repeating, and goes on forever as far as we know. So the most accurate way to leave it is as e to the 7th power. Okay, just like that, instead of trying to come up with a decimal approximation, which is what your calculator would do. All right, let's move to problem 3. And you notice again in problem 2, before I jump ahead, this is to the 5th power here. So we don't have to worry about potential negative solution. All right, so here we have log of x to the 8th equals 64. So we have an even power here, so this is going to be a little different in the end. But we're going to start the same. We're going to do 8 times the log of x and set that equal to 64. Then I'm going to divide both sides by 8. The 8's here are going to cancel, and we're going to get the log, the base x, equal to 8. Now another way we could write log with the base of x, not base of x, log of x. Another way we could write log of x is log with the base of 10 of x. Okay, so when they don't write the base, you don't have the base written here, it's actually 10. So when we write this in exponential form, we're going to write 10 to the 8th power equals x. Well, what is 10 to the 8th power? Well, it's a 1 with 8 zeros after it. So it's actually 100 million. Now here's the thing with this solution here. Because we're taking x and we're raising it to an even power, if x were negative, when raised to an even power, it's going to be positive. So one of the solutions is x equals positive 100 million. The other solution would be x equals negative 100 million. Okay, so this one does yield 2 solutions. All right, let's keep going. All right, this next one we're doing log base 2 of x to the 9th power equals 81. We want to solve for x again. We're going to take the power here, 9, and put it in front. So we'll do 9 times log base 2 of x. Set that equal to 81. We're then going to divide both sides by 9. And we'll get log base 2 of x equal to 9. So if I write this in exponential form, I'm going to write 2, the base, to the power 9 equals x. So 2 to the 7th power is 128. 2 to the 8th power, we multiply by another 2, is 256. And therefore 2 to the 9th power would be 512. So x is going to equal 512. Okay, let's keep going. Problem 5, we have log of x cubed equals 18. We want to solve for x. So we're going to take the exponent here, 3. We're going to multiply by the log of x and set that equal to 18. We're going to divide both sides by 3. And we'll get the log of x equals 6. Okay. Now, the base here is 10. So when we write in exponential form, we're going to write 10 to the 6th power equals x. So x is going to equal 1 with 6 zeros after it, which is 1 million. So 1 million. Now, if you notice here, this is to the 3rd power, so we can't do negative 1 million, because if we raised negative 1 million to the 3rd power, we'd get a negative value, and we can't take the logarithm of a negative value. So you only have the negative solution when you have an even power there. Okay, let's move to the last problem here. If the natural log of x cubed equals 81, take this, 3, we'll do 3 times the natural log of x, set that equal to 81, divide both sides by 3, 3's cancel here, so we get the natural log of x equals 81 divided by 3, which is 27. The base for the natural log is e, so we're going to write e to the 27th power equals x. And we're going to leave that as our solution. Okay, that's it. Hopefully this video helped you out. If it did, please like and subscribe.